Greetings everyone, welcome to tvmathshub. Today we want to look at some pure mathematics revision questions, and we shall begin with this question here. The question says use calculus of small changes to estimate log 2 of 7.95. We shall do this one by letting y to be equal to log 2 of x. So we first of all let y to be log 2 of x, where this x here is a value that is very close to 7.95, and which value can easily be expressed in terms of 2. So the value that is close to 7.95, it can either be higher than this or it can be lower than this, but that value should be close to 7.95. And that value can easily be expressed in terms of 2. So the value that is very close to this, that can be easily expressed in terms of 2, that value will be 8. Meaning that if we let y to be log 2 of x, our x will be represented by 8. So that means that our y will be log 2 of 8, and log 2 of 8 is same as log 2 of 2 to power 3. So 2 to power 3 represents 8. So you will drop this one here, and this will be 3 log 2 of 2. So that is what we have, and this will be giving us 3 times 1, and this will be 3. So y will be equal to 3 if x is equal to 8. Next, we shall deal with differentiation. So how do we differentiate y equaling to log 2 of x? So we differentiate this by first converting this one here in terms of natural logarithm. So we need to recall some few facts about logarithm. We know that if we have log a of b, this can be expressed in terms of log c, or you can change the base here to be base c. If you say log a of b is equal to log c of b divided by log c of a. So likewise, if I have this, I can write this as logarithm of e of x divided by logarithm of e of 2. So this one can be written as ln of x divided by ln of 2. So that is what we are having. But still, you can write this as 1 over ln 2 times ln of x. So this is your y. So your y is 1 over ln 2 times ln of x. So when you differentiate y with respect to x, you will get 1 upon ln of 2 times 1 over x. Remember, how do we differentiate ln of x? You differentiate the function, which is x, then you divide by the same function. So when we do that, we shall be able to get this, which you can easily write as x ln of 2. So this is your y dx, and that is what we shall get when we differentiate y with respect to x. We can now easily get the value of delta x, that is a small change in x, and that will be easily obtained by looking at the difference between the value that we have, which is 8, and the value that we are given, which is 7.95. So looking at this, 7.95 can be represented as 8 minus 0.05. So which means our delta x will actually be negative 0.05, because this can be written as 8 plus negative 0.05. So this is same as 8 plus a small change in x. So a small change in x will be represented by negative 0.05. So that will be a small change in x. So after getting a small change in x, we can easily get a small change in y. We know the relationship between small change, that is delta y over delta x. This is approximately equal to the y dx. And if that is so, then it means small change in y is approximately equal to the y dx, then times a small change in x. And this implies that since we already have the y dx, and we already have delta x, then we can have a small change in y. So you will substitute the y dx is 1 upon x. We already know that is 8 ln of 2 times negative 0.05. So this will be able to give you a small change in y. So we shall be able to get a small change in y as that. So from there, let us get the final answer. So the final answer will be log 2 of 7.95 will be approximately equal to log 2 of 8 plus a small change in y. So log 2 of 8, this value here, we already saw that is 3 plus a small change in y. So a small change in y, we have got that as negative 0.00902. So when you get 3 minus this, you'll be able to get this. And this will be the value of log 2 of 7.95. So that is how we use calculus of small changes to find such expressions. Next, we are given the question, the radius of a cylinder is increasing at the rate of 1 centimeter per minute, while the height is increasing at the rate of 0.5 centimeter per minute. Find the rate of change of the volume of the cylinder when the radius is 5 centimeters and the height is 10 centimeters. So let us look at the solution. We understand that the volume of a cylinder is given by V, which is equal to pi r squared h. But we realize that from the given information, the height and the radius, the height and the radius are all changing. So the height and the radius are all changing. So it means this one is changing with respect to time. This is also changing with respect to time. So looking at this, it means R and H are all variables. So if we want to get the rate of change of volume or the dV/dt, it means we shall need to differentiate this given expression, that is V equaling to pi r squared h, with respect to the changing variables, that is R and H. So R is a variable, H is a variable. So since they are all varying with respect to volume, then it means our dV/dt will be equal to, we shall put the pi out, which is a constant value. One, we shall use a product. This is a product function because R squared and H are all varying. So this will be treated as a product of two functions. So what we shall do is, one, we shall maintain h, then we differentiate r squared with respect to time. So when you differentiate r squared with respect to time, when you differentiate r squared with respect to time, you will get 2r dr dt. So that is 2r dr dt. Then this one will be maintained constant, plus then now maintain r squared constant, then differentiate h with respect to time. And that will be r squared times dh dt. So that is what we get as dv dt, which will be pi into 2r dr dt times h plus r squared dh dt. So we already given that the r dt is 1, dh dt is 0.5, r is 5, and h is 10. So next, we shall simply substitute these given values. So when we substitute these given values, we shall be able to remain with dV/dt, which is equal to pi into 2 times 5 times 1, then times 10, plus 5 squared times 0.5. And when we do that and compute, we shall be able to remain with pi times 112.5. So therefore, we shall be able to remain with dV/dt, which is 112.5 pi, that is centimeters cubed per minute. But you can easily also get the value for this by multiplying 112.5 with the pi value, and we shall be able to remain with 353.4292. centimeters cubed per minute.
Yeah.